China has spent the last few decades quietly reshaping the limits of human engineering, and the results are impossible to ignore. Across its huge territory, China has launched infrastructure projects so large and complex that they've changed landscapes, redirected natural systems, and even redefined how cities function. These projects aren't just about size or speed, they reflect a mindset that treats infrastructure as a long-term investment in national strength, stability, and future growth. Each project solves a real problem, whether that problem involves water scarcity, overcrowded cities, geographic barriers, or transportation efficiency. Together they show engineering ambition can reshape an entire country. One of the most notable developments is China's underground city and tunnel networks. In cities like Beijing, surface spaces become limited due to population growth and dense development. Instead of expanding endlessly outward, China expanded downward. Beneath Beijing lies a vast system of tunnels that function as transportation routes, emergency shelters, storage areas, and commercial spaces. These underground structures were originally built during the Cold War for civil defense purposes, but they have since been expanded and repurposed. In cities like Chongqing, underground metro stations and shopping centers sit dozens of meters below ground and resemble futuristic halls rather than basic transit stops. Some tunnels extend more than 60 meters deep, cutting through solid rock. The full scale of these underground networks remains classified, which adds to the sense of mystery surrounding them. What is clear is that China has created an entire parallel layer of urban life beneath its cities, allowing surface areas to function more efficiently. The Three Gorges Dam stands as one of the most controversial and powerful symbols of China's infrastructure ambitions. Built across the Yangtze River, it's the world's largest hydroelectric dam. The dam stretches over 2 kilometers wide and rises nearly 200 meters high. Its reservoir extends for hundreds of kilometers and displaced more than 1 million people during construction. The scale of the project is so immense that scientists calculated it slightly altered the Earth's rotation due to the redistribution of water mass. The dam generates more than 100 terawatt-hours of electricity each year, supplying power on a scale comparable to entire countries. At the same time, the dam has caused environmental damage, including habitat loss, landslides, and challenges to river ecosystems. Supporters argue that the energy and flood control benefits outweigh the costs. Critics point to irreversible ecological harm. Regardless of perspective, the dam permanently altered China's geography and demonstrated the nation's ability to execute projects once considered impossible. Another engineering marvel is the Hong Kong-Zhuhai-Macau Bridge. Stretching 55 kilometers across the Pearl River Delta, it connects 3 major cities through a combination of bridges and underwater tunnels. Engineers faced a unique challenge because the area serves as a busy shipping and aviation route. Instead of blocking traffic, they designed a section of the bridge to descend beneath the sea into a submerged tunnel. Massive prefabricated segments were placed on the seabed with extreme precision, forming a tunnel that allows ships and aircraft to pass overhead. The structure required hundreds of thousands of tons of steel and was built to withstand earthquakes, typhoons, and ship impacts. What once took several hours of travel now takes less than half an hour. The bridge is constantly monitored by sensors that detect stress and material fatigue, allowing maintenance before problems arise. This project represents a shift toward intelligent infrastructure that actively monitors its own condition. Water scarcity has long challenged northern China, where nearly half the population lives, but only a small portion of the nation's water resources exist. This South-North water transfer project was China's answer to this imbalance. Rather than relying on conservation alone, China decided to move water across the country on an unprecedented scale. The project consists of 3 massive routes that carry water from the south to the north through canals, tunnels, and aqueducts spanning more than 3,000 kilometers. One section even carries water beneath the Yellow River, allowing one river to flow below another. The central route alone transfers billions of cubic meters of water each year, supporting cities like Beijing and reducing the risk of severe shortages. The project displaced communities and altered ecosystems, which sparked criticism. Supporters argued that without this intervention, northern China faced long-term water collapse. The project stands as the largest manipulation of water systems ever attempted by humans. Guizhou province in southwestern China is often called the Kingdom of Bridges because of how dramatically it has transformed travel in a region filled with deep gorges and steep mountains. Traditional road construction was difficult and inefficient, so engineers chose to build upward instead. Guizhou hosts many of the tallest buildings in the world, with some hanging more than 500 meters above river valleys. The Duga Bridge is one of the most famous, rising higher than many skyscrapers. Engineers used advanced methods, such as launching cables across wide chasms and tensioning massive steel supports to complete these structures. These bridges turned isolated areas into connected regions and also became major tourist attractions, proving that infrastructure can drive economic growth as well as mobility. The Sichuan-Tibet Railway is one of the most challenging rail projects ever attempted due to the extreme environment it crosses. The route runs through very high-altitude terrain with low oxygen levels, active earthquake zones, avalanche-prone areas, and unstable permafrost. Engineers are building long tunnels through shifting mountains, including one that stretches over 20 kilometers through a seismic zone. Temperatures along the route vary from extreme cold to intense heat, making construction even harder. The trains will use pressurized cabins to ensure passenger safety. Once completed, the railway will reduce travel times from days to hours and greatly improve connections between Tibet and the rest of China. Beijing Daxing International Airport shows how China combines speed, scale, and planning in modern infrastructure. Completed in less than 5 years and opened in 2019, it's one of the largest airports in the world. Its star-shaped terminal design reduces walking distances and improves passenger flow. Natural lighting lowers energy use, and high-speed rail links connect the airport to central Beijing in minutes. Designed to handle up to 100 million passengers each year, Daxing Airport stands as a strong example of efficient and forward-thinking infrastructure. At the top of China's transportation achievements stands the Shanghai Maglev train. This train operates without wheels, relying instead on magnetic levitation to float above the track. By eliminating physical contact, the system reduces friction and allows for extremely high speeds. In regular operation, the train reaches speeds exceeding 400 km per hour, while test runs have gone even faster. The trip from Shanghai Pudong Airport to the city takes just minutes, offering a faster alternative to road travel. Passengers experience smooth acceleration and minimal vibration, highlighting the advantages of magnetic technology. China introduced this system in the early 2000s, long before many countries considered maglev technology practical. Current development efforts aim to push speeds even higher for future long-distance routes. When we talk about speed and fast travel, China's fastest hypercar truly stands out. The Yangwang U9 is an electric supercar from Yangwang, a luxury brand owned by BYD. It has a bold, sharp design and looks every bit like a machine built for performance. The most extreme version produces an incredible 2,978 brake horsepower and can reach a top speed of 308 miles per hour. The standard version is less practical but still very impressive, delivering 1,288 brake horsepower, which is more than enough to compete with many of the world's fastest cars. What unites these projects is not just their size, but the philosophy behind them. China approaches infrastructure as a foundation for long-term development rather than a short-term expense. They send a message about capability, confidence, and ambition, and influence how the world views China's technical expertise and willingness to push boundaries. While debates about sustainability and impact continue, there's no denying the scale of achievement involved. These projects stand as reminders that the future of construction belongs to those willing to think bigger, build faster, and commit fully to the challenges ahead.